Welcome, Algebra 2. Let's take a look at Chapter 5, Section 4, solving equations containing radicals and rational exponents, working our way towards radical inequalities. As we start off solving these, we're going to start with a square root equation. Here's a square root. And then we'll work up to other types of roots like cube roots and fourth roots and so on. But the first thing I'm going to do is I notice that there's a number outside of my square root. So what I want to try and do is isolate that square root. Isolate means put it all by itself. Anything that is outside of the square root goes to the other side. We have 3 times the square root of x. How do you get rid of that? Well, you divide by 3. That will leave me the square root of x equals 21 divided by 3 is 7. Once the radical is isolated, then I think, how do I get rid of a square root? Well, the opposite of a square root is to square. If I square one thing, I square both things. I square the left side, I square the right side. So I'm going to square the left side, I'm going to square the right side. And since I'm feeling extra generous, I'll do one side, you do the other. Okay, so do you want to square the left side or do you want to square the right side? I thought you would pick the right side. Our last step is to solve. And the way we solve it is we go ahead and do what we said. We square it. 7 squared is 49. You left me the easy part. When you have a square root and you square, they're inverses. They undo each other. When you square root and you square, all it leaves you is what's underneath, which is x. See, I had the easy part. You had the hard part. You had to think 7 times 7, which wasn't so hard after all. How do we check our work? Take your answer, plug it in here for x. So on my calculator, I can put 3 times the square root of x is 49. And when I hit enter, I should get 21. If so, I know my answer is good. So put this in your calculator. 3 square root of 49 is 21. And it is. Here's why. 3 times the square root of 49 is 7. 3 times 7 is 21. I know my answer, x equals 49, is good. Anytime we do a new equation, I always like to plug it in the calculator when I'm done, see if I'm doing it right. You try. Your steps are ISS. Some of you might be very familiar with ISS. You know, isolate, square, solve. I don't know what you thought it stood for, but that's always what it stood for. Isolate, square, solve. Hit pause, come on back when you're ready. As I look at my square root, I see that there's a 2 outside. My first step would have been dividing by 2. I hope that's what you chose to do. 10 divided by 2 is 5. Isolation is done. Here's how I know. There's nothing outside of the square root on this side. The plus 9 is inside the square root. It's not outside. So the radical is isolated. When it's isolated, here's what it means. You'll have something equals everything else. That's what isolation is. Now, S, we square. We will square both sides. You square one side, you square the other side. I'm feeling extra helpful. I'll do one side, you do the other. Oh, you're going with the 5 squared, aren't you? Yeah, 5 squared is 25. That's good. Square root of x plus 9 squared. Remember, a square root and a square cancel each other out. It simply leaves us x plus 9. To finish it, minus 9, minus 9. Whatever 25 minus 9 is, should be our answer unless we made a mistake. I'm thinking it's x equals 16. Let's plug it in and check it to find out and see, did it turn out actually to be 16? And that's kind of an important step as we're solving these types of equations. We might get an answer that actually we plug in and find out it doesn't work. When we had those kinds of answers with quadratic formula, they were called extraneous solutions. Like you got negative time, negative distance. We could get the same problem here. When we're solving a square root or a cube root equation, there's a chance we create an answer that doesn't really solve the problem. It's kind of like you say, Mr. Brown, can I get a drink of water? And I hand you a piece of paper. Didn't really solve the problem, right? That's a possibility with these types of problems. Let's take our 16, plug it in right here. So on my calculator to check it, I'm gonna go 2 square root, plugging in 16 plus 9. When I hit enter, if I get 10, I know that my answer x equals 16 is good. If not, I throw it away and call it an extraneous solution. Or it tells me I goofed up. That's another possibility. Let's see. 2 times the square root of 16 and 9 is 25. 2 times, square root of 25 is 5. 2 times 5 is 10? Yeah? Okay. You don't have to do it that way, but you should be able to check it on your calculator this way. 2 square root of 16 plus 9 equals 10. So, graphically, let's see how this would look. If I went to Desmos and I typed in y equals 2 SQRT, there's square root, x plus 9, there's my graph. If I type in the other side of the equation, y equals 10, I can find that they intersect when x is 16. Kind of cool, huh? Left side of the equation, right side of the equation, they intersect when x is 16. That's what it means. Maybe it's not a square root. Maybe it's some different type of root. Well, the process is going to be pretty similar. We will use the inverse power as we try and solve radical equations. We have the cube root of 2x minus 5. That's all inside the cube root. Minus 2 is outside, equals 3. We're still going to isolate. Isolation will still be first. So how do we isolate? Let's add 2 to each side. Why am I doing that? Because it's on the outside of my cube root. Cube root of 2x minus 5, that's all under the cube root, equals 3 plus 2 is 5. Now we can't say that we're going to square, because squaring would get rid of a square root. So we need the opposite of a cube root, which would be a cube. We'll use the inverse power, P for power. We'll still isolate, but then we'll use the inverse power. Power would be to the third. Power to the third. Whatever power you use on one side, you use on the other side to keep it fair. Now, I'll do one side, you do the other side. Are you catching on that this side is simply going to be 2x minus 5? When you have a cube and a cube root, they cancel each other out. They're inverses. So this is 2x minus 5 as I try to solve. IPS, not ISS. We're moving out of ISS. We're moving up to the isolation, power, solve. Calculator, 5 cubed. 5 times 5 times 5, or use your little exponent key. 5 to the third power, 125. So we keep going, trying to solve. When we're done, we'll check it out. What would you do to solve? Hopefully you'd say add 5. So 2x equals 125 and 5 is 130. Divide by 2, divide by 2. I got 65. Wow, I remember being 65 like 20 years ago. How do you check your answer? Well, that's where it gets a little tricky. I'm going to take that 65, put it right here, but we got a cube root. So let me do that on my calculator with you guys, and then we'll see if we're doing it correctly. All right, cube root. To get a cube root, we need to start with a 3. And then we go to not the square root, but the funny little root that has the x. It's on your exponent key. So 3, funny little root with the x. That gives me a cube root. We had parentheses that we have to put in. 2 times 65 minus 5. Close your parentheses. So there's the cube root of 2x minus 5. And then we had outside minus 2. When we're done, we're hoping to get an answer of 3. We did. We know we're right. All right, you try. Isolate, power, solve. Hit pause. Come on back in a minute when you're ready. All right, welcome back. First up, we look at our radical. Here's our 4th root. 3x plus 1 is under the radical sign. So what's outside of it? The 5. It's got to go away. Isolating. We have the 4th root of 3x plus 1 equals 1 minus 5 is negative 4. Now we need to get rid of that radical sign. The inverse power of a 4th root would be raising it to the 4th power. Raise this to the 4th, raise this to the 4th. Whatever your little power is, that's the inverse of your roots. These should be the same. That way they cancel each other out. The 4th root of 3x plus 1 to the 4th power is 3x plus 1. That's the easy side. You can do it without a calculator all day long. Here you might want a calculator. Parentheses, negative 4, close your parentheses, to the 4th power. 4 times 4 times 4 times 4. I got 256. You get 256? Lastly would be to solve. Minus 1 minus 1. So 3x would equal 255. Divide by 3. See what you get. 85 sound about right? So, how do you check and see if this answer is legit, right? We talked about how you sometimes create extraneous solutions, and sometimes you're thirsty, but I hand you a piece of paper. Didn't solve your problem. Or sometimes I do the easy part, you do the hard part, right? Doesn't solve your problem. Let's take our 85, plug it in here. We need a 4th root. On your calculator, you put 4 with your funny little root. You need to start the parentheses. It only starts it for you with a square root. It doesn't start it with a cube root, 4th root, 5th root, any kind of root other than a square root. We have 3 times x is 85 plus 1. Close your parenthesis. That will close the root. Then hit plus 5. When you're done, hit equal, and we'll see if you got it right. All right, I'm going to do it on my calculator. 4, funny little root, parentheses, 3 times 85 plus 1, close parentheses, plus 5. I got 9. Did you get 9? We were supposed to get, supposed to get 1. Sometimes when you're solving these, you're creating extraneous solutions. This is not right, which means guess what? This is not right. This is an extraneous solution. There is no solution to this problem. Can't be done. There's no x value that will make this actually work out. Graphically, here's how I can do it. I can put in my 4th root. Got to go to functions, go all the way down to the end. Here's my little root. I want the 4th root of 3x plus 1. And I want on the other side, I needed plus 5. On the other side, I wanted y equals 1. you can see these two graphs do not cross, they do not touch, they do not meet. Y equals 1, and my other graph does not intersect anywhere. There is no solution. Math, the only place where people buy 60 watermelons and no one wonders why. Isn't that the truth, right? If math would grow up and solve its own problems, that'd be great. Yeah, we'll get right on that. Solve your own problems, math. Until then, you and your group get to solve a few problems. Take about 15, maybe 20 minutes tops, and work on solving radical equations. Hit pause, coming back to your notes when you're done with your group work. All right, welcome back. Let's see, what's different here? That's right, we have an x on each side, so life just became fun. When you have an x here and here, well, we've got lots of work to do. We will still look to isolate. Is there anything outside of this radical on this side? No? All right, so isolation is done. Now we'll look to use that inverse power. Well, we have a square root. I guess I could square it. Square this side. Square this side. Oh, this is going to be great. This will be epic. I love it. I'll take the left side. I'm feeling extra helpful. When you have the square root of 2x plus 7 squared, all you get back is 2x plus 7. On the right side, you get to multiply x minus 4 times x minus 4. You remember the FOIL method? Why don't you pause for a minute and go ahead and FOIL it out. All right, welcome back. Let's see if we got it. X minus 4 times x minus 4. X times x is x squared. 4 times x would be 4x. 4 times x would be minus 4x. And lastly, negative 4 times negative 4 would be 16. Looking for like terms. There they are. So we get x squared minus 8x plus 16. What do you do from here? Well, if it's an x squared, we're probably getting two solutions. We're going to put all the x's and the numbers on the same side as the x squared. X squared is here. All of these go over to the right. The reason is I don't like having a negative x squared. Negative x squared is hard to factor. I'll subtract 2x from each side. In fact, I'll go ahead and subtract 7 from each side while I'm at it. That leaves me nothing over here. And on the right, negative 8x minus 2x is minus 10x. 16 minus 7 is 9. Good news, everyone. Ha, you missed me saying that, don't you? We can factor this trinomial. Things that multiply to 9, but add up to negative 10. Multiplies to 9, adds to negative 10. Your choices: negative 1, negative 9, negative 3, negative 3. Who multiplies to positive 9, but adds up to negative 10? Negative 1, negative 9. Good news, everyone. We can now take each factor, set it equal to 0, and solve to find our two different x values. I'll take my first factor. We're up to the solve part for s. First factor, x minus 1, set it equal to 0. Add 1 on each side, x is 1. Second factor, x minus 9 equals 0. Add 9 to each side, x is 9. There's my two solutions. The bad news is they might not both work. Maybe they both work, maybe one of them works, maybe neither of them worked. How do we know? We get to plug both of them in and try it out. Which one do you want to start with? The 1? Okay, sure. Plugging in 1 here, plugging in 1 here. We'll check it. If we get the same number on each side, we know 1 is a keeper. Then we'll try our 9. So, check it. 2 times 1 plus 7. Work this out on a calculator. I'll wait for you. Square root of 2 times 1 plus 7. I got 3. Now put this in your calculator. 1 minus 4. 1 minus 4 is negative 3. Does 3 equal negative 3? Nope. Straight-A solution. Uh-oh. I hope 9 works. If not, then there's no solution to this problem. Let's take our 9, plug it in here, plug it in here. Square root of 2 times 9 plus 7. I'll wait for you. Go ahead, put in your calculator. I got 5. How about this side? 9 minus 4. I got 5. Does 5 equal 5? Yes. This is my solution. One of them worked, one of them didn't work. That's often what happens when you have these multi-step equations involving radicals. You and your group, how about you work on solving radical equations, part 2. Good luck. Have a great Viking day. Bye, guys.